All right, so here we're going to do three problems from the homework, and kind of help identify when do you use which formula, because we have a lot, right? We have the payout annuities formula, we have the annuities formula, we have the compound interest formula, and then we have the simple interest formula. And we had two of these, but you can just always use the simple interest over time formula. We're going to start with problem number 6 from the homework. So how much will $1,000 deposited into an account earning 7% interest compounded annually, how much will that be worth in 20 years? So whenever we're depositing things is either interest, simple or compound, or annuities. When we're withdrawing things, that's payout annuities, okay? So it's not payout annuities, and we're only depositing it once. An annuity is like a retirement account where we're making monthly payments a lot of times, but we're only depositing a lump sum here. So it's just going to be that compound interest formula. Again, it's compounded annually. That's the key phrase. Compounded interest with K, it's annually, so once a year. So let's copy that formula down. Copy this down to our notes. P sub n equals P naught times 1 plus R over K to the NK, and then we fill in the blanks. How many years? 20 years. So N is 20, replace N with 20. Now, what is our principal? What's our initial investment? $1,000 times 1 plus R, 7%, 0.07. Compounded once a year, so K equals 1. And again, 20 years, and K is still 1. You can just type this into your calculator or Desmos all at once, and we are going to do exactly that. Go over to Desmos and say, I want to save this annuities formula. I want to save this compound annuities formula. Let's do it over here. We're going to get 1,000 parentheses 1 plus 0.07 /1 tab parenthesis up here 20 times 1. We can type it in exactly like it looks, or we could have simplified it a little bit first. But either way, we're going to round to the nearest cent and say that it's going to be worth approximately $3,869.68. So this is a nice interest rate, right? We deposited $1,000. After 20 years, we've almost quadrupled our money. And that's compound interest. That's problem number 6. Next, let's look at problem number 12. You, yes, you right there, deposit $1,000 every year. So right off the bat, we're not just depositing once. We're depositing every year. That's annuity. Okay? You deposit $1,000 every year into an account that's earning 8% interest compounded annually. You're going to have to use that annuity formula. So maybe right now, I immediately say, okay, what's my annuity formula? Let's write down the annuities formula because I know I'm going to need it. So I scroll to page 5 in our notes for this week, and I copy it down. P sub n equals D times 1 plus R over K to the NK minus 1 divided by R over K. This is the formula we need. Okay? What's the information? We're depositing $1,000 every year. D is our monthly or annual, it's our payments. It's $1,000. And if you want to make a little note to yourself that yes, it's every year, you can. R is our interest rate. We have 8% interest rate, which is 0.08 as a decimal. K is how many times it's compounding. Annually, once a year. And N is how many years. Our A wants us to do 10 years. So we're just replacing all of these letters with their corresponding numbers. tilted myself a little bit. That's going to be D, which is 1,000, times 1 plus R, 0.08, divided by K, which is 1, raised to the parentheses here are optional when you're writing it by hand, but they're helpful for Desmos. N times K minus 1, like so. Just replacing it all with the numbers that they should have. Now again, you just look above, make sure that everything was replaced correctly, and then we type this into Desmos. All right. So we already typed in the annuities formula way up here. This was already an annuities formula, so we can actually just edit, if we wanted, just edit the numbers. So now we're doing 1,000. Our interest rate is now 8%. We're not doing it daily, we're doing it annually. That's 1 again. This is now 10 times 1. And then we're dividing by R, which is again 0.8, divided by K, which is now 1. And before you write your answer down, look at Desmos. Look at your calculator. Make sure that this matches this. Yeah, looks like it matches. Well, then this is our answer. $14,486.56. That's our answer to part A, I think. Part A asked, how much will you have in this account after 10 years? We're depositing $1,000 every month and we're gaining interest. Then after 10 years, we can have this much money in our account after 10 years. Part B, how much total money will you put in the account? Careful with this one. This is how much will you have in the account. Well, part B is asking how much of that money, how much of that 14 grand, how much of that money was our money? How much of our money did we put in? Well, we're putting in $1,000 every year for 10 years. Right? We put $1,000 per year for 10 years. So how much did we put in total? 1,000 for 10 years. We put in 10,000. Whoa, I almost added an extra zero. We put in 10,000 of that. So I guess that means 4,500 in interest. I'll take it. And that's what part C is asking. How much total interest will you earn? Well, that's going to be, we have this much now, and we put in this much. What's the difference? The difference is the interest. Our interest is going to be the $4,486.56 of interest. That's problem number 12. Yes, if you put in 100,000 and you only have 14K afterwards, here's a problem. No extra zeros here. Last problem we're going to do is problem number 16. How much money will I need to have at retirement so I can withdraw? We see withdraw, we think payout annuities. Withdraw 60K a year for 20 years from an account that has a certain interest rate. As soon as we know we're going to need compound annuities, we're going to go over here. We're going to find our compound annuities formula, our payout annuities, sorry, payout annuities formula, and we're going to copy that down. Okay, let's copy that payout annuities formula. P naught, the initial amount we have before we start withdrawing, equals D, our monthly payments, our monthly withdrawals, times 1 minus 1 plus R over K to the negative NK. Parentheses here are optional in the exponent. divided by R over K. This is the formula we're going to be using here. So we just have to look at the homework to see what is what. The homework question is asking, how much do you need in your account at the beginning? How much do you need in your account at the beginning? That's this. Oh, I didn't switch. That's this. This is how much in the account at the beginning. So P naught is what we're looking for in part A. So let's just fill in everything else. D is how much I want to withdraw. We're withdrawing 60,000 a year. That's our D here. 60,000 a year. 1 minus 1 plus. What's our interest rate? 8%. How many times per year? It said compounded annually, once a year. Raised to the negative n. How many years was it? It was 20 years times k, which is 1. A lot of parentheses here. All divided by r, which is still 8%, divided by k, which is still 1. So you have to type all of this into Desmos or your own calculator or whatever you want. And remember that box number 2, that was our payout annuities formula. So we can just edit this box if we want to save a little time. This is now 60,000. This is now 0.08. This is now 1. This is now 20 and 1. And the bottom is 0.08 and 1. And before we write down our answer, we look back at our paper and make sure that our paper looks exactly like what's typed in to the calculator. Once we've verified that, we write down our answer. That the initial amount we need in this retirement account, or whatever kind of account it is, needs to be $589,000. This is how much needs to be in the account if we want 60K a year for 20 years. And we're still getting interest on the remaining balance at a rate of 8% every year. This is how much we need. This is our target for our retirement account. That's part A. Part B is asking how much total money will you pull out of the account? Which is not this much money. This is how much money is at the start of the account, but we're pulling out more than this. This is how much is in the start of the account, but we're still getting interest every year, 8% of this. That's a lot of interest. And every year we're withdrawing more, so this gets smaller, but we're still getting interest. The question is, how much do we pull out total? Well, 60K a year for 20 years is how much we took out. Right, 60K a year for 20 years. This is how much we've withdrawn. This is how much was in it at the start, but this is why we invest it. We should be taking out a lot more. 60,000 times 20 is $1,200,000. 1.2 million. So even though we only had 600K, we're actually getting about double that value out of this account, which is nice. It's pretty cool. We had a pretty, and that's what's going on here. So part C is asking how much of that is interest. Well, 1.2 million total. And we put in 589,000. Right? This is how much of our money was in the retirement account or whatever kind of account it is. What's that difference here? Type that into a calculator. I need to type it into a calculator because I don't know the answer. $610,911.16. So a little under 600K was the money we put in the account. A little bit more than 600K was the interest we got off of it. So That's a nice little ratio to me. Unfortunately, this ratio is also connected to next week's material on loans. And when we talk about loans and interest, it's going to be some bad ratios that you're not going to want to see. All right. So you should have everything you need to do the homework. Let me know if you have questions or if you're struggling with something. All right. Good luck.